All right. Hey everyone, welcome to another deep dive. Today, I think you're part of multiple projects, but we have a guest with us who goes by Skeletor. Um, and you're with DeFi Wonderland. Is that
That's
correct?
correct. Yeah, that's correct. And yeah, as well, we have multiple projects. I think today we're going to just discuss our only and probably I think like once in a lifetime internal public good project that we ever did at DeFi Wonderland. But yeah, instead of doing kind of the God's work, we usually partner up with different protocols and try to work with them to build interesting solutions.
Cool. Yeah. How long have I guess, how did you get involved doing that? And I guess more specifically, how did you get involved kind of doing the Oracle piece?
Yeah, so I been involved in the space for 5 years now. I used to be a core developer at Yearn Finance.
Yeah.
And then I joined DeFi Wonderland because I really loved what they were doing and basically collaborating with a bunch of projects. So you are always kind of building on something new, on the bleeding edge of technology, even in crypto, which is still like something pretty new for a lot of people. And now I'm Wonderland joined as kind of the lead tech researcher. So I mostly do research and development, and I help the research team and the development team kind of come out with cool designs and architectures for different solutions to different problems for our partners. And one of the things that I was really kind of into, even in Yearn, were like both automation and on-chain oracles. Uh, it was kind of, I think, I'm not sure if you remember, but there was this oracle called Keeper Oracle a while back, which was kind of in between Uni V2 and Uni V3. The only it
Yeah.
was like literally exactly like Uni V3 oracles. The only issue is that it needed to be maintained because you need to basically constantly update the price, and that was like really costly. So it got shut down fairly quickly because nobody wanted to pay for that, obviously. And then Uni V3 launched, so everyone basically jumped into that. So from kind of the inception of on-chain oracles, I being kind of obsessed with that, and we really needed like basically a fully decentralized on-chain solution for some projects that we wanted to build and we were building. Bless you. and
Sorry.
and yeah, that's why we came up with price oracles that solves basically the problems that UniV3 oracles kind of have.
So I guess the project for people out there is what, price.oracles?
Oh, it's we usually use kind of funny domain names, so it's
Yep.
oracles.rip.
Or yes. And put it up here so everybody can see it.
Nice.
Yeah. Um, cool. And I guess, yeah, I mean, we can just kind of jump in. I think that would be the most fun, and we can just ramble on. Um, I'm just gonna pin myself here. Uh, so I guess before we get started, and for to kind of give some context, what was the purpose, I guess, of oracles.rip? Like, was there a specific app you were building this for, or were you trying to build just more generic price oracles in general?
Uh, Kind of both.
Okay.
We yeah, so we wanted to build kind of a more generic oracle in the sense like literally it was a like optimistic generic oracle for a different project that yet we cannot disclose, but soon is going to be out.
Right.
But then we started thinking about what if we needed like on-chain prices, right? And what would be the best way, because it didn't make sense to have an optimistic model to just basically bring data off chain that was already on chain, that arbitrageurs and everyone was basically taking care about, and like everything was paid already on chain by the people doing the swaps, etc., etc. So it was like just like a free lunch, right? It just needed some tweaks to make it work for everybody. And that's where we decided to start tinkering a little bit about Uni V3 oracles and what were the issues with that. And right when we were kind of finishing the first design, proof of stake came along and basically changed everything. And luckily, it also gave us like a really good opportunity to come up with a kind of a signal filtering or manipulation correction design for the oracles that allows us basically to make the Uni V3 oracles manipulation proof, kind of. We just
I mean, for people who are watching this that maybe didn't watch Torgen's Uniswap episode, which I think I'll reference back to, and it gives a pretty good overview of it. But what is the problem with current Uniswap V3 oracles, especially regards to the proof of stake world?
Yeah, absolutely. Yeah. By the way, go and check Torgen's episode, so I don't have to repeat all the things he said.
Just briefly,
really,
you can,
but briefly. So basically, Uni V3, how it works is you will get basically the price of the pool, basically of a pairing of assets, let's say WETH DAI. So you will need to know, let's say, for example, how much DAI is worth one Ether, right? And this price, basically in Uni V3 words, is called tick, which is basically the column you are into. Is only updated on the next block. This is done just to be able to protect against, let's say, flash loan manipulations, in the sense that let's take 2 blocks, right? On block 0, you will have a bunch of swaps or whatever. The pool on that specific block ends in a specific tick. So let's say the pool right now it's on tick 10. On the next block, independently of whatever swap or whatever interaction in the pool, let's say somebody wants to provide liquidity, someone wants to withdraw liquidity. Tick is with a final K.
Oh, that, yeah. These are, never mind. Keep going. I don't want to interrupt you.
No worries. So independently of what happens on the next block, the actual price, quote unquote, which is the tick of the previous block, gets saved before anything else happens. And this is done just to have this protection against like same block or flash loan attacks, which is pretty neat. This is not. So let's say let's say tick 1 is priced $10 or whatever, just to make it easier, and then 20, 30, blah blah blah, and then we can have a column of blocks.
Block over here.
Yeah, so block would be, let's start with 0 and then 0, 1, 2, 3, 4. Cool. Yeah, and then you can have like another column at right saying, let's say, observation.
And this would just be the lagged price, right?
Exactly, yeah. So it will be, like it will be nothing, right? Yeah,
empty. Or just null.
Null, yeah, then 10, 20, etc., etc.
Yep.
Awesome. So with that, basically, you are kind of protected against single, let's say, single block attacks, kind of. And obviously, the way you are protected is because in between blocks, there is an arbitrage opportunity, right? So MEV bots or whoever can come and can see, hey, this pool is unbalanced, and can basically generate a trade that balance back that pool. So nobody in their right mind will try to arbitrage or manipulate a pool in this sense, because it has kind of a lot of danger that can be avoided. So go watch Torgen's talk on how to avoid that if you're planning to do some malicious stuff. But besides that, it's really tricky to know for sure that you are not going to be arbitraged and lose basically all that arbitrage opportunity. The thing is, with proof of stake, you can for sure know and be sure that you're not going to, let's say, have a reorg, like a reorganization of blocks after your attack. So you can know for sure that the next block is going to be your own. And this gives you the opportunity to, on the previous block, generate this manipulation, because you're for sure going to be able to arbitrage yourself back into the next block, because you're the block producer of that one.
Right. So
And
with proof of stake, you could know that these two blocks you're going to be the producer of this block. So then in this block, you can go and manipulate it. And the one that you control, you can make sure that you're the only person that can arbitrage it back.
exactly, yeah.
Yep.
Exactly. So, and that's kind of impossible basically to protect in Uni V3 natively. It's a pain in the ass to handle while using TWAPs as well. You need to basically increase the window of observation, so the amount of time you're calling the TWAP, which also gives you more delay on the price that you're actually getting, because obviously you're like referencing older ticks or older prices. But it kind of gives you the average out price of a manipulation, so it doesn't really matter. But it does actually, because if you have if you're using a TWAP for something that needs to be really, really specific, even a 1% or 2% deviation on the quoting can be used for an attack. It's just a matter of how much money you have, right? It's like 1% on 1 million might not be a lot, but 1% on 1 billion might be so worth. So yeah, it just depends on the scale, basically.
I think that was a phenomenal, quick little summary of the risks of Uni V3 in this world. So I guess the question now, how do you guys fix this?
Awesome. So how we fix it, we need to introduce a new column called Accumulator. So the accumulator is actually what gets saved into the Uni V3 observation array.
I
So
think I spelled that.
Perfect, yeah. So what we actually have in observations are just kind of as you said, the lagged ticks, but those don't really matter because they're just for sake of explaining. The accumulator, what it does, it's super, super simple. Let's say each block is, or let's say that block time is 10 seconds, just to make it easier, not 12 seconds in POS. So the accumulator, the only thing it does is multiplies the tick by the time elapsed between the previous observation and the current block timestamp. So let's say the accumulator starts at 0. So we can start accumulator 0. Yeah. And then the following will be 100 because the tick, 10, because the tick was 1. And the difference in block time is 10. So it will be 1 multiplied by 10 seconds.
So it would be this one multiplied by the tens, if there's 10-second block times.
Exactly. Yeah. Let's clarify that just in case.
1 times 10 times 10. So this would be.
No, just times 10 because it's just the tick. Yeah.
So the 1 is the tick?
Yes. Tick multiplied by seconds elapsed. So difference, delta time, let's say. Yep. And that's 10.
10.
And then what it does is just adds. So it will be 10 plus on the below line below, it will be 10 plus, so basically the previous value plus, now let's say the tick is 2 times 10. Yeah,
2 times 10.
Yeah, and that will give you
30.
Yeah. And you can continue. Basically it's now 30 plus tick is now 3 times 10, 60.
Okay. And then
now,
60 plus 4 times 10 equals 100. Okay.
Yeah, exactly. So basically those are the values that get saved on the accumulator. And if you notice, let's say if you had a manipulated tick, let's say on the next one you will have 100 plus, I don't know, 1 million times 10, which is insane. For example, if you had a manipulated tick, or do 1K or something like that.
Well, is the tick, what's the tick here? Sorry, my lights are going crazy.
No worries.
What's the tick here? Is this is the price, or what's the difference between the tick and the observation here?
Yeah, so observation, you can, it's kind of the delayed price, let's say. But those both price and observations are like just concepts for us to understand. The tick is, so if you have, I want to get like super into the math of Uni V3, but the tick is either the square root of the current price or the other way around. I don't really remember for sure. But the thing is, it's like it's
some
almost
price transformation.
Exactly, yeah. But from negative, let's say negative infinity to positive infinity. And depending on the tick, you do this like weird calculation on a different base on Uni V3 to get the actual price of the asset. But let's say it's just the column of liquidity on Uni V3 that has both upper and lower ticks.
Cool.
So if you wanted to make it just more clear, we can do negative 1K times 10.
Okay.
Yeah, and that will give us like 9,900 or something like that, probably.
Negative 9,900.
Exactly, yeah.
Yeah, okay.
Yeah. And then let's say the tick goes back to being 4, for example. So you have negative 9,900 plus 4 times 10.
4 times 10. Yeah.
Yeah.
So yep. That would be
negative 9,860.
all right.
So that is pretty obvious that something weird happened there, right?
Completely.
Yeah. So what we do actually, all those values that you just actually saved, so 10, 30, 60, 100, minus 9,900 and minus 9,860 are actually values in an array of observations. So what we do is on chain, we have let's say a manipulation correction script that you can send them an index of an observation. So let's put index numbers on those. So let's start with 0 and then all the way.
Yep. So I'll put index numbers of 0, 1, 2, 3, 4, 5, 6. And then these guys, we're going to store all these in an array, right?
Exactly, yeah. So that lives on the Uni V3 contract. That's like something native of Uni V3. That's how it works.
Does it store them forever, or does it just do they only store like the last 30?
That's a good question. So the accumulator array or the observations array has a length that is defined by something called cardinality, and it just loops around that. You can increase the length of the array. This has basically this will give you obviously more room to store observations. So you can know, for example, that if you increase the observations array by increasing the cardinality, you will have X amount of cardinality times 12 seconds of like minimum observation time. Obviously, not all blocks produce observations because you need like to swap and to move the tick or to add liquidity or remove liquidity on every block to do that. There are no pools are that active, so you have like a longer maximum time window always, but also increasing the cardinality a lot might increase or will increase the cost of quoting the oracle a little bit. It's not crazy, but it will increase the cost a little bit. So yeah.
So what would be like the number on like the USDC contract? Would it be like what's the cardinality here? Like
not sure, but it can be like 200. It's like a good number.
Okay.
So on price oracles, we start all the pools with a cardinality of 64, which at least for sure it will give you 10 minutes of time.
Yep. No, that's cool. I was just wondering what the range was, but
Oh yeah, the thing is, since nobody's actually using these pools or these oracles for Uni V3, the cardinality is crazy. You can check the cardinality of a pool that has a shit ton of liquidity, and it might be 10. You know, like the default one, because nobody cares.
Right.
Like nobody's using Uni V3 oracles. This is the issue, and it's like a really, really good solution. It's obviously it does cost gas to quote it, but you don't have to pay Chainlink or any other like external provider of oracles for data on chain. And it's like
Just Chainlink costs money.
it does cost. Yeah.
Joke, but
Yeah. So yeah, basically what we do is we have this, let's say a wrapper on top of the Uni V3 oracle or the pool oracle. That what it does is you can send them an index on the observation array that you think is manipulated. So in this case, we will send the index number 5.
okay. So what's the function call we're gonna do? I guess it's
Apply correction.
by correction 5.
And
Okay.
yeah, and you send as well how many observations you think are manipulated. Now we can send 5,1 because just one. Nice.
Cool.
And obviously you need to send the pool as well. Sorry.
Sure.
But yeah, let's say this is the WETH dipole. So you say, yeah, this is WETH dipole, whatever, index 5 and just length of 1. So this contract, what it will do is it will go to that pool and it will say, hey, give me the indexes, let's say 4, 5, and 6, for example. It's kind of a little bit more complicated than that, but let's just simplify that and say, okay, give me 4, 5, and 6. And with that, you can calculate the delta on those, right?
So it'll return 100 negative 9.9K negative 9.8K.
Exactly.
Right?
And then it will calculate the delta, which is basically on that delta negative 10K, and then
Okay.
Just 40 probably. Yeah.
What is it?
40, which is the next one.
Oh, the next one down here.
Yeah, all the deltas.
Okay.
Yeah. And with that, you know that there was like this manipulation in between those two observations. Let's also add on the left of the minus 10K the delta of the previous. So let's add as well 40 on the other end. So let's also grab
okay.
the index 3. So it's
you would know.
clear. Yeah.
40.
Exactly. Yeah. And now you say, hey, like the delta here doesn't really match. And besides this, we also get kind of the corrected TWAP, but we can go explain that a little bit later, perhaps. And we say, hey, okay, so we were, let's take the accumulator as a speed, right? We were going at 40 miles an hour, and then suddenly in one block or in one observation or in this like specific time, because we know each observation has the timestamp saved into that. So from this time to this time, we jumped to minus 10K miles per hour. Like what the hell, right? And then we went back to 40 miles an hour. Like what happened here? And we do a bunch of calculations to know if this change in quote unquote speed was like over the boundaries of what we basically consider a manipulation. And then what we do is we say, hey, okay, on this period, like it was effectively a manipulation happened in this specific observation, and we save that time, so the both the start and the end of that observation with the amount of the accumulator that needs to be corrected. So in this case, it will be minus 9,860 probably. Oh, sorry, plus 9,860.
Okay.
So this is the value that we would need to apply if you ever quoted, let's say, if you ever quoted in between the, let's say, the index 4 and 6, we will need to add that value to the accumulator to basically correct for that exactly for that weird price.
Yep. And then I guess, yeah, so I mean, the parameters, you brought up a whole bunch of good points. So I guess the parameters for like, was it manipulated? Because, you know, how would you tell the difference between the prices all of a sudden dropped
Exactly,
versus,
yeah.
you know, so I guess that would just be dependent on the parameters that you guys have in place.
Yeah, so right now everything is fixed. So everything is a constant value on the contract. And how we know if there was a manipulation is because it returns to the average, right? It returns to it's a spike. If there is like a rug or the price just moons or drops or whatever.
So by this,
and
you can tell it returns.
exactly, and it never goes back, then it's not a manipulation, right? It's just that the price suddenly either yeah, it went to an extreme. We do have plans to add a flag for this specific scenario, so saying,
Yep.
hey, like the pool went crazy, just like brace yourself, just if you want to continue operations do, but we are just raising a flag on a specific function. But the pool in that sense is going to be so it's going to throw a is manipulated flag as well, because the current tick doesn't match with the TWAP tick.
Right.
And now we can go into how we do calculate the actual TWAP here, which is the corrected TWAP or the corrected quoting that we do on this Oracle wrapper.
Sure. So I think, but I guess, you know, like when you do it returns to the median, you know, does that have to return within a block, or do you have that, is that another variable? You know, do you usually have like 5 blocks or 5 accumulator ticks to return?
What do you mean to return?
Like here, there was 1 block of manipulation, but let's say there was, it was really high and then it was really high again,
Yeah.
and then it returned.
Yeah, that's fine. You just
That would be okay.
Yeah, you send 5,2, and
Okay.
that's it. And probably the accumulator, it's going to be double if the tick maintain itself on over 2 blocks period. It doesn't necessarily, so here's the trick. So it doesn't necessarily have to be a new observation that it's manipulated, because let's say you get like 5 blocks in a row, right? And you want to manipulate the pool over 5 blocks.
Right.
You wouldn't apply an observation on every block. You would just manipulate it once, just filter out all the transactions that are trying to arbitrage you back, and on the last block you will arbitrage yourself back. So on the Uniswap Oracle or let's say observations array, we will only see one observation that was the one manipulated, but the next observation that you're going to see is going to obviously have more than 12 seconds of delta time, because obviously more blocks elapsed between those 2 observations.
But I think that's, I don't know if that's necessarily fair, because you would only do 1 observation if you were trying to manipulate the traditional Uniswap V3 Oracle. Whereas if you knew how this one worked and you were trying to manipulate it and you got 5 blocks in a row, wouldn't you just, you know, like how would you do that? You would, I guess then you would hit it every time, right?
Yeah, but the thing is, you can just instead of sending 5,1, you would just send 5,2, and our calculations will work the same. The only difference is that instead of just grabbing, we'll just grab 1 more observation to the calculations.
So could you do like 5,10? Would that work?
Yeah, we had done like let's say 5, I don't know, 200, and it worked.
Oh wow.
Yeah. It's just a for loop that goes through all the observations. I think the only way you could basically break the system in that way is like having, I know, an infinity or like really big array that just overflows the gas cost, but I don't think it's possible. So yeah, so we just needed to return somewhat soon. But here comes the other issue, right? So you would say, hey, what if you have, I don't know, 100 blocks in a row, which is obviously pretty insane, but it might happen or whatever. Then
Yeah,
yeah, you're
150 block reorg, didn't you see?
yeah, exactly. Them, but yeah. So let's say it happens and you have like a lot of blocks. This is something that we took into account. So we do have some caveats around using price oracles, which is instead of doing a simple Uni V3 quote like from 0 seconds ago to 10 minutes ago, which is what you usually do as parameters when quoting, you will need to do, or you will need to leave out a 2-minute window on all the quotes. So you would do from 2 minutes ago to 12 minutes ago to be able to get a 10-minute TWAP. So we always have to include this 2-minute delay, and this 2-minute delay equals to 10 blocks. These 10 blocks are the 10 blocks that we use to find and correct these manipulations. So in the case that there is a manipulation that lasts for more than 10 blocks, this can be either by somebody getting a lot of consecutive blocks or just the market not properly arbitraging back the pool or whatever, which is weird. You will start, so this manipulation will start to leak into the observations that you are quoting. So this is dangerous. This is why we do require a minimum amount of liquidity to be seeded into the pools of price. And maybe we can talk that later about like how setting everything up or how this basically looks in practice. But yeah, so this is the main difference between, yeah.
Yeah, so there's like a 2-minute delay, and that's the optimistic window for basically who can call this? Anybody?
Anybody, yeah, that's open.
Anybody.
We do run like fairly well incentivized keepers to call that function, so they will be handsomely paid if they successfully report a correction.
Okay.
But it's open to anyone, like anyone can call this function. Yeah.
And there's 2 minutes for them to do so.
Yeah, maximum, but yeah.
Very nice. No, I was thinking like, could you just get like, how handsomely are you rewarded on it?
Probably like 4 times the gas you spend. We can set that parameter up
Okay.
however we like, because it's just like the periphery keeper job contract. So
That's not that handsomely rewarded. That's like,
for just running a bot, it's pretty good.
I was saying like, if at any point you do know that you're going to be the next person to mine it, you should just go in there and make an error, like a trade that, manipulates the oracle, and then go claim a correction.
Absolutely, yeah. Probably like the fees that you're going to spend doing that are way more than what you are going to get.
That's what I was wondering. Yeah, is there
Yeah.
if you were paying these guys thousands of dollars or something, it could be worth it.
No. Yeah, we are not that rich yet. Also, this is yeah. So all of these, that's a good one though. Like all of the price oracle automation is basically self-sustained. All the fees that are basically recycled from the full range position and the concentrated positions that the protocol has, like a percentage goes to the people that seeded it or that locked concentrated liquidity, but another big chunk of the fees go into increasing the cardinality, so making this array of observations longer, so the people using the oracle can quote far back in time or whatever. Also increasing the amount of full range liquidity, which increases the health and the cost of manipulating the oracle.
So here I'll go just leave some of this up. So I guess that would be, you're kind of getting into the user side of it.
Yeah.
So you guys have there would be what's the name of the contract? Oracle contract or?
Yeah.
Or,
yeah, we just literally call it Oracle. Yeah.
Okay. And then this would be the Uni V3 contract over here, and then the user's contract, say it's a stable coin or something, they would be reading the Oracle, which would then be reading the Uni V3 contract, correct?
Exactly. And in a perfect scenario, the oracle just goes to Uni V3 and goes back and doesn't apply any correction, because it doesn't make sense for anybody to start messing around with the pool, because they know they won't get anything out of that, right?
Yep. And
so
then what
there is-
else? Yeah, so no, that's super cool. I think so he has to pay a fee to read?
No, everything is free.
Everything's free. So
Yeah,
so there's
besides the tiny bit extra gas that you spend,
okay.
yeah, it's free.
But there's so that's completely free, and then anybody can run it, but you guys are basically just funding the keepers on your own at this point.
No, so here comes the other part of the system. So we have this as, let's say, the periphery. So the oracle is actually periphery. We can swap it. It doesn't really besides the correction, it's not really in the protocol itself. As we said, it's just a wrapper for the Uni V3 oracle. Then the other issue of Uni V3 pools is that you really need the liquidity to be there and to be well positioned. Ideally in a full range position. You can argue, then we can argue and see the math, that you don't really necessarily need like a 100% full range position. You can do like a semi full range position and it will work the same. But either way, let's say it's just a full range position. What we do is we also have like these protocol contracts, which is the, let's say, the pool manager, where the seeders are going to seed this liquidity into the pool. This liquidity will stay there almost forever.
So these are separate contracts.
Exactly, yeah. The pool
managers, and then they deposit an LP into there.
Exactly, and they deposit a full range position. Yeah.
And that's just because just to make sure that it's a little bit harder to manipulate, right?
Exactly, yeah. You never run out of liquidity, basically. So the amount of liquidity right now needs a minimum of a total of 50 Ether. So it will be like 25 WETH and 25 of the other token that you're wanting to pair, right?
Yep.
Besides this, we also have a contract called the lock manager, which allows kind of basically a liquidity mining mechanism for seeders to incentivize people to lock concentrated liquidity as well into that pool. And how it works is we have as well an on-chain strategy that manages these positions. Right now, it's super simple. But in the future, we can propose migrations and the contracts which are self-governed. So the pool manager is governed by the people seeding in that contract. They have voting power, depending on how much LPs they provided. And the lock managers also have voting power depending on how much concentrated liquidity they provided. And they can do like some few actions, but the main action that the lock managers can do is to self-deprecate themselves. So if they do this, what this will first create is it will basically remove the lock manager connection on the pool manager, and it will instantly deploy or atomically deploy a new one. This old lock manager, it will start this unwinding process and basically start removing or burning the Uni V3 positions and recovering all the LPs. In the, like, obviously they will have some impermanent loss or whatever, but then when everything is accounted for, people can come and can withdraw their tokens back. So there is a way to recover the liquidity if you are using the lock manager. If you're using the pool manager, that liquidity pretty much stays there forever, but that's basically it makes sense to do that, right?
And this is for the reason you would do this is if you control some of your tokens and you want to incentivize it.
Exactly, yeah. So let's say you're you're a new protocol that has a token and you want that token to be included in a lending market. And there is this, let's say, Euler or whatever lending market that does, or let's say a permissionless lending market that can allow you to create or add whatever collateral if you have a price pool or an oracles.rip pool, right? So you will come and you will say, hey, I will deposit or I will mint X amount of my protocol tokens. I will pair that with 25 ETH. I will create the price pool. And then what I can do is, hey, I also want to have more liquidity in my pool because I don't know, I want better, obviously with more liquidity, you will have better pricing on that pool, and also you will gain more fees because some of the percentage of the fees that the concentrated positions create go back to increasing the full range, which basically gives the seeders more fees. So it's kind of a nice kind of flywheel effect. And we have a bribe system as well on top of the lock managers, where this protocol can go and say, hey, I will give you X amount of my tokens if you deposit X amount of liquidity. Just like generics, synthetics kind of contract.
Nice. Cool. Are there any, I guess I have to ask, is there any way in this Oracle contract, any governance actions, anything that can be controlled, or is it literally just apply corrections?
No, it's either apply corrections and remove corrections, which is only used for really, really old corrections, just so not have to basically loop, like check the array. So if you have a correction that is, I think, 2 weeks old or something like that, we just remove that, just to make it less gas expensive for whoever is quoting. But yeah, it's like something that it's fixed. We might deploy new versions of the oracles, so protocols integrating might have or might need a way to switch this address up if we ever release a new one.
Well, they wouldn't need to. I mean, this one would still work correctly.
It would still, yeah, exactly. It will still work, but if they need like better features, features or whatever that we are going to deploy, yeah, they can. But yeah, that will work forever. So yeah.
Yeah, I mean, this was one of the things. This was one of the problems that we had. You know, we had talked to some people who were thinking about using Uni V2 as an oracle, and a lot of people, you know, not that that was a great idea for other reasons, but one of the big reasons that they chose against using Uni V2 was that they knew Uni V3 was eventually coming out, and they didn't, you know, they would have to change their addresses and add in governance, and it was, so yeah.
So the only risk here is that they're like Uni before or whatever other AMM that has a better oracle comes along and basically takes the spotlight, and I know people decide to start migrating the pool managers. The pool managers can have a way to basically recover the liquidity, but that requires, let's say, the owners of the pool manager, which is, it's a bit weird, but it requires, let's say, Wonderland to propose a specific migration contract that then each individual pool manager contract has to vote on to migrate the liquidity to. So it's a pain in the ass, and this is like, it's on purpose, basically. And if we don't propose a migration, you are not going to get that money out of the pool managers. And that's, and even if we propose a migration, there is like either a month or 2 months time lock period until you can execute that. After obviously proposing on chain that you're going to migrate.
Super cool. All right. So what have I missed? We got like 10 minutes until we hit the hour. Yeah, where, you know, Oracle related, and then, you know, I know you were recently, before you jumped on, you were talking about doing cross-chain stuff as well.
Yeah.
Does this have anything to do cross-chain? Could you use this cross-chain in any way yet?
Nice. Yeah, that's an excellent question, and it also gives me kind of a way into this new topic, which is, so let's say, so price oracles will work on any chain that has Uni V3, right? It will also work on Uni V3, let's say, available chains that do want to basically provide liquidity. Maybe you have your governance token or your protocol token. You don't want to provide liquidity on all the Uni V3 chains plus the 25 Ether. So it really doesn't make sense for, let's say, an AMM to use price oracles on the chains, because probably you won't have all the same available pools on all the chains. This is why, this is one of the reasons we created something called Sidechain oracles. Then I can share you the link afterwards, and you can add that to the description so people can check that. This is open source, and this is a way basically to create a virtual UniV3 pool on any chain that will receive the observation information from a parent chain, let's say from L1. So you can have all the liquidity on L1, and you can bridge that observations information into let's say a virtual UniV3 pool on any chain. It can be a chain that does have UniV3 but doesn't really have the liquidity, or it can be a chain that doesn't even have UniV3, right? Obviously, this has a little bit of a delay because you need to you have the delay of the bridge, and we are using Connext for this right now. So it's not like a huge delay, but it does have a delay. But it's better it's better than not having any information, right? Or just having to spend liquidity to have an on-chain oracle. Or if you don't have UniV3, then yeah, it's better to using probably any other solution. Like
so this would be like if you have a smart contract on Polygon and you need a the WETH, an ETH US dollar one, you could just refer to the Oracle contract over on Ethereum mainnet, and you guys basically have created a smart contract that reads those values from this Oracle. Right?
It's a little bit different. So what we do actually is we have a UniV3 virtual pool, literally, like it behaves exactly like a UniV3 pool on Polygon, but only for the quoting. It doesn't have liquidity, it doesn't have anything. And what we do is we from time to time,
you pull all the Uni observations over.
Yes, kinda, but we only pull them, let's say, once every day or something like that, or if the price diverges from the last let's say observation migration or observation bridging. We do have.
So why would you pull the UniV3 and not the Oracle?
No, actually, we pull the Oracle. Yeah, we pull the correct. Okay. Yeah, the correct observations. Yeah.
Well, because I was like, why would you have to make corrections on both?
Yeah, so actually these two projects are separate projects. So Sidechain Oracles is currently working, and it's what we are using to support Keeper multi-chain. That what it does is, so Keeper minting works on L1. Depending on how much LPs you are providing, it will mint you some amount of credits over time. The amount of credits depend on the pricing of Keeper at a specific TWAP window. And for that to happen on different chains, we needed to bridge the TWAP observations, which was a pain in the ass. So we decided to create these sidechain oracles that basically allows us to easily deploy Keeper on any chain. The code will stay the same because for the Keeper contracts, they are still interacting with a UniV3 pool. The only difference is that UniV3 pool is actually like a sidechain oracle virtual UniV3 pool that we seed the information to from L1 using Connext.
Yep, and Connext, that was an episode I previously did. If you guys watch it, for most chains, they just use the native bridge. So it's
exactly.
Yeah.
Let's say it's just a bridge. Yeah. So right now, Sidechain Oracles is using UniV3 pool directly, but we will switch when we deploy price oracles. We will switch to use that for the pools that do have a price oracle on, just to be extra safe.
Nice.
Yeah. So that's how it works.
That's super cool. Yeah. So there's obviously a big delay on these ones, though, right?
Yeah.
Yeah, because you would have the delay that's normally built in here plus the bridge delay, and then you're only bringing it over. So it's useful for some things.
Exactly. Yeah.
But maybe not everything.
Yeah.
Then, cool.
So ideally, you always want to have the liquidity on the chain that you are executing your code, and you want to have the oracle and the arbitrage happening on the pool that you are quoting to have the more precise price that you can possibly have, right? But if that's not possible, you have these solutions. Or for example, for Keeper, we don't really care because we are using a 5-day TWAP window. So for us, if it has like 30 minutes delay, it doesn't really matter, right? It's just like a tiny bit more
For sure.
or less than the 5-day TWAP, so it's okay.
Cool. You know, as we kind of wrap it up, I think, you know, like how the question I like asking, you know, how, I guess, in building this has your view of bridges or oracles changed? You know, like where do you see kind of the future of this stuff? Do you think we'll just be using liquidity pools for oracles, or do you think there's some better solution out there?
So it changed somewhat. Probably I became more of a maxi in regards of if you have the data on chain, use an on-chain oracle or use let's say a CK solution that can prove on-chain using the Patricia trees that the information was there, and you have like a specific program that runs and calculates the TWAP depending or calculates whatever based on on-chain data. That's perfect. For all the other things, you can use whatever oracle that you want. But what we found as well, and the project that we are building around optimistic oracles, is that most oracles today do have kind of let's say a paid entry point, either by having to use the token of the specific contract for let's say voting or for disputing the information, or by just having to go through an onboarding process that requires you to pay, etc., etc. So the developer onboarding is not really optimal there, and it's probably making some projects kind of have second thoughts on using those oracles. So we are building kind of or we want to build, sorry, a generic type of optimistic oracle that anyone can plug any dispute module or whatever they want into it. So it's pretty modular. It's as well a public good. So yeah, that should be
Cool.
pretty exciting.
Yeah, no, that works. I think I think reality.eth has something similar. You know, they're super good too. They're another older project that has you can sort of plug in your dispute module and things like that. But no, I like it. And anything I forgot before we wrap it up? I tried to touch everything.
No, I just wanted to say that yeah, just like at Wonderland, we are always kind of trying to build interesting stuff or collaborate with interesting projects. Our URL is defi.sucks as well, and our funny URL. We believe that the current state of DeFi is not ideal, and there are like a bunch of stuff that needs to be taken care of or improved. So if you want to collaborate, or if you're looking for a job at a nice company, just hit us up. We are more than happy to chat with anybody. And yeah, I'll be at ETH Denver these following days. And then there is like this Oracle Summit convention in Berlin in late June as well. Are you guys going?
We will be there.
Awesome. So. Then we'll meet there as well. Are you guys going to ETH Denver as well?
I am not, but the Teller team, my team will be there. So
awesome. Yeah, as well. Yeah, so that's it.
Super cool. Well, thank you very much. Call it a wrap.
Thank you so much.